Let us take a set and create something new that we call a subset of that set. In the definition, we can see that if you have two sets like A and B, then set A is called a subset of set B, and we write it as A as a subset of set B if and only if every element of the set on the left-hand side, which is A, is included in the second set on the right-hand side. Symbolically, we write it this way. A is a subset of B. It means that for all elements like X, if X is in A, then you can conclude that X is a member of B as well. Visually, take a look at this example. Set A includes 1, 2, 4, and set B, which is a larger set, includes 1, 2, 3, 4, and 5. So set B is a larger set, includes a smaller set, A. So A is a subset of B. Another definition for you. A set that has nothing in it is called empty set. It's denoted by empty set, or you can use curly brackets with nothing in it. Note that the cardinality or size of the empty set is 0 because it has 0 members. It doesn't have any member in it. Also note that empty set is going to be the subset of any set. Empty set can be assumed as a table with no element in it. For example, in this data frame or in this table, the order ID is empty, the order date is empty, customer, there is nothing, no information here. So these are all examples of empty sets. You have a set which is called priority, and there is nothing in that set. You have a set called total amount, and there is nothing in that set. So these are all examples of empty set. Set has nothing in it. When we write A is not a subset of B, it means that you can find at least one element like X, which belongs to the set on the left-hand side, and that element doesn't land in the larger set B. So we write X is a member of set A, but X is not a member of set B. So it means that set A is not a subset of set B. Let's go back to algebra. Remember the definition of natural numbers, whole numbers, and integers. The set of natural numbers is starting at 1, then 2, then 3. These are all counting numbers. The set of whole numbers start at 0. So you have 0 on the counting numbers, and it is called the whole number system. Then we add negative numbers and we introduce integers. So what's the relation between natural numbers, whole numbers, and integers? Natural numbers is a subset of whole numbers, but whole numbers is not a subset of natural numbers because whole numbers has 0, but natural numbers doesn't have 0. What about integers? Natural numbers is a subset of integers. Whole numbers also is a subset of integers, but the set of integers is not a subset of these two sets. By definition of rational numbers, this is a set that includes all fractions of the form P over Q, such that P and Q are both integers, and the denominator is not equal to 0. Well, all other numbers are called irrational numbers, like square root of 2, pi, Napier number, and so on. We can visualize basically the relationship for these sets using this diagram here. Natural numbers is a subset of whole numbers, is a subset of integers, is a subset of rational numbers, and irrational numbers, including square root of 2, square root of 17, pi, Napier number, and so on, forms irrational numbers. The union between rational numbers and irrational numbers is called real numbers. We're going to talk about union and intersection later. Okay, suppose you have two sets. We say that set A is a proper subset of B if and only if every element of A is in B, but there is at least one element in B that is not in A. Consider set A to be including C, D, F, G, and set B including F and J. The third set C includes D and G. Answer the following question and give the reason for your answers. First of all, is B a subset of A? Is every element in B land in A? Set B has F and J. F is here, but A doesn't include J. So the answer is no. B is not a subset of A. Why is that? Because J is a member of B, but J is not in A. Part B, is C a subset of A? Set C is here, D and G. Well, D is here and G is here as well. So the answer is yes, because every member of C lands in A. It means that C is a subset of A. So the answer here is no. The answer here is yes. The next question. Is C a subset of itself? Well, the answer is yes. Every set is going to be the subset of itself all the time. And finally, D, is C a proper subset of A? Well, the answer here is yes. Why is that? Because there are elements in set A that are not in set C. So C is going to be a proper subset of set A. Okay, let us move on to next slide. Consider the following set. A is positive integers. B is the set of all integers that are in between 0 and 100 inclusive. C is the set including 100, 200, 300, 400, 500. Question says, evaluate the truth and falsity of each one of the following statements. Is B a subset of A? Is this set land in A? Is set B included in set A, or set A includes set B? The answer here is false. Why is that? Because 0 is part of set B, but it's not included in the positive integers. So the answer here is no, it's not true. C is a proper subset of A. C has 100, 200, 300, 400, and 500. Is C a proper subset of A? Well, this is a true statement. Remember the definition of being proper subset. Each element in C is a positive integer, and so is in A. But there are elements are in A that are not in C. For example, 1 belongs to A and 1 is not in C. So C is a subset of A, but there is no possibility that they're equal to each other. So C is a proper subset of A. C and B have at least one element in common. Take a look at C and B. This is B and this is C. Okay, take a look at the answer. The answer is true. Why is that? Because we can see that 100 is included in set B and also is in set C. So we can find at least one common member, which is 100, that belongs to the intersection of B and C. And finally, is C a subset of B? Okay, take a look. C includes 100, 200, 300, 400, 500. But if you list the members of B, you have 0, you have 1, you have 2, you have 3, you have 4, 5, 6, and you're going to stop at 100. So it doesn't include 200, for example. It doesn't include 300. It doesn't include 400, and so on. So it is a false statement. Perfect. And we saw that every set is a subset of itself. So the last statement is true. We can say that A is a subset of A, B is a subset of B, C is a subset of C. So it's always true. Remember that we say A is a subset of B. It means that for every element, like X in the smaller set, that element lands in the larger set. That is the definition of being a subset. Question says, is 3 a member of this set? The answer is yes. Why is that? Because I just see 3 lands in this set. So this is a true statement. Question says, is number 1 a subset of set including 1? Please note that on the left-hand side, you have an object which is not the same as the object on the right-hand side. Here you have a set, so you're trying to compare a number and a set, which is basically wrong. When it comes to being a subset, you have to have the same object, which is a set on the left-hand side. Is set including 2 belongs to the set including 1 and 2? The question says, hey, is this object is a member of this set? But the elements of this set are 1 and 2. There is no set including in this set. So the answer is no. You only have 2 elements in the set, which are 1 and 2. But set including 2 is of different object. Is set including 3 is a member of the set including 1, set including 2, and set including 3. Yes, I just see it right here. Set including 3 is indeed a member of this set. I just see it right here. So the answer is yes. Next question, is 1 a member of set including 1? Of course, I just see it right here. So the answer is yes. Perfect. Is set including 2 a subset of set including 1, set including 2, set including 3? Well, this set has one member, which is 2. I don't see this specific member on the right-hand side. So the answer is no. The only element in the set on the left-hand side is number 2. But I don't see number 2 as an object here. Objects here are 1, set including 2, and set including 3. These are of different objects. Is set including 1 a subset of 1 and 2? The answer is yes. This member is basically lands in the set on the right-hand side, which is just right here. So the answer is yes. Now let's take a look at the next question. Is 1 a member of this set on the right-hand side? The set on the right-hand side has a set in it and also a number in it. So the answer is no. 1 is not a member of this set because the objects in this set are a set and a number. Next question, is set including 1 a subset of set including 1 and another object which is set including 2? The answer is yes. Based on the definition of being a subset, I see the exact same element in the smaller set as a member of the larger set. So the answer here is yes. And take a look at question J. Is this set a subset of this set? Is the set a subset of itself? The answer is yes. So any set is a subset of itself. Now consider you have two sets like A and B. We can create a new object using Cartesian product. The Cartesian product of two sets is denoted by A cross B, and the definition is as follows. It is the set of all ordered pairs like A and B such that the first element is in the first set and the second element lands in the second set. So you're taking elements from the first set and elements from the second set, and you're basically forming ordered pairs or points in the plane. Let's take set S to include 2, 4, and 6. Set T, which includes 1, 3, and 5. If I ask you to form the Cartesian product between S and T, following the definition, we're going to list all the ordered pairs. The very first ordered pair is 2 and 1. 2 comes from the first set, and 1 comes from the second set. The second ordered pair is 2 and 3. 2 comes from the first set, 3 comes from the second set. You continue this process. The next pair is 2 and 5. 2 comes from the first set, 5 comes from the second set. You continue this process. 4 and 1, 4 and 3, 4 and 5, and the last number is 6. 6 and 1, 6 and 2, 6 and 3, and then 6 and 5. So this is the Cartesian product between two sets, S and T. Consider the following two sets. Set A includes A, B, C, and set B includes 1 and 2. The Cartesian product between them includes A and 1, A and 2, B and 1, B and 2, C and 1, C and 2. We can visualize this way. Set A on the horizontal line and set B on the vertical line. The elements of set A are A, B, C. So you have A, B, and C. On the vertical line, you have set B including 1 and 2. Well, okay, A and 1, A and 2 are the very first two ordered pairs. Then you can work on B and 1, B and 2. So the second two dots, B and 1, B and 2. And finally, you have C and 1, C and 2, and that's it. As easy as that, we can visualize the Cartesian product between two sets. Again, remember from what you learned in algebra. If you have some points, they're basically coming from the Cartesian product between R by itself. For example, the origin, 0 and 0. The next point is 3 and 0. Here you have 3 and 4. If you change the order, 4 and 3, you're going to get 4 and 3, which is a new dot here. So the order is very important when it comes to ordered pairs and Cartesian product between sets. And in general, the Cartesian product between two sets is not commutative. It means that in general, A cross B is not the same as B cross A.